like to go ahead and introduce our next speaker, Peanut McCoy from Azusa Pacific, who will be presenting on the effects of faith integration, discussions on students' understanding of science and how that has an effect on their understanding of science. So please go ahead, Mr. McCoy, and start, and we'll have 5 minutes of questions towards the end.
Thank you. And hello, everybody. So I'm going to tell you about some of the effects that our faith integration in a physics class at Azusa Pacific has had on our students' understandings of the nature of science. And I'm going to go a little bit more quantitative on this. So to get us started here, there's 2 key terms that I need you to know for this talk. First is epistemology and then faith integration. I'm going to start with the epistemology. So what I mean by epistemology is students' understandings of the nature of science and the nature of learning science. So this is a pretty complex construct. Of course, it's something that we want our students to know as science majors. And I'm going to attempt to measure this using the epistemological beliefs assessment for the physical sciences. I'm going to call that EBAPS. So this is a survey that's available from the physics education research literature. It's been validated. There's national data out there. It measures these 5 axes. Each of these has a pretty strongly held expert-like belief and more novice-like beliefs. So first, axis, structure of scientific knowledge. For example, on that, scientists are well aware that scientific knowledge is hierarchical. There are some things that are more fundamental than others. A novice-like belief on that might be that it's all just a bunch of disconnected trivia. Continuing on, we've got the nature of knowing and learning, real-life applicability, evolving knowledge, and the source of ability to learn. I want to especially focus on that one. There, the expert-like belief would be you can learn science by putting effort in, and hard work is going to lead to more learning. The more novice-like belief on that might be that it's inborn, the ability to do science, and there's nothing you can do to change that. So I'm going to use this EBAPS survey, and I have a research question on it. How do faith integration activities that we do in introductory physics courses actually impact the students' epistemologies? Of course, this epistemologies are also important to us. There are many discipline benefits to having good scientific-like epistemology. So students with more expert-like epistemologies have better metacognition, they learn more, they're better problem solver, they fail less, they're more likely to be retained. All of these things are really important to the major itself. Okay, shifting gears here a little bit, faith integration. So I've thrown this term out there, and in case you're not as familiar with this, I'm going to define this kind of broadly as an academic exercise in which we're exploring the relationship between faith and the academic discipline. Ideally, this should be a reciprocal interaction, so the faith is informing the academics, and the academic discipline can also have some informing of the faith, as we've heard in the previous talk. Okay, so let me talk a little bit about what we do with this. So the study that I'm doing here is taking place in the context of an introductory physics course, and what we do for faith integration in that course is short daily discussions on this theme of characteristics of scientists. So every day, we'll take about 5 minutes at the beginning of class, post a question, and discuss that question as a class. After class, then the students are sent to our learning management system. They continue a threaded discussion online. It does count for a portion of their course grade, 4% of their overall grade they get for doing 16 posts. And since we're doing these every day, we have 36 to 39 topics that we discuss throughout the semester. This is part of a larger faith integration curriculum that we have in our physics major at Azusa Pacific that we've centered around 4 themes. So first theme is characteristics of scientists. What habits and traits do scientists need in order to be successful? Second trait we do in our second course, nature of science, sorts of things like what assumptions are we making and how do we know what we know? And then in our third course, we do science and society and theological implications of physics. So we're doing these short discussions in our introductory courses. In our upper level courses, we continue and we come back to these themes so that every one of our courses has some engagement with at least one of these 4 themes. Okay, as an example, this is one of the daily discussion topics from the Physics 1 course. So I'm just going to take a moment to read it here. Professional scientists are regularly subjected to advice and constructive criticism. Advice and criticism may come from professors while in college, research advisors while in grad school, journal referees, research collaborators, or competitors. How a scientist responds to advice or criticism can affect their reputation and the quality of their work. When you receive advice or criticism, how do you deal with it? And what does the Bible have to say about giving or receiving advice or criticism? So some things to notice here. We have a reflective piece. We have a use of the Bible as a way to inform this, that hopefully would inform the student's behavior as a scientist in training in this case. And we also have, why does it matter for the discipline itself? So we're getting this reciprocal interaction between the faith and the discipline. Okay, so let me shift into the study a little bit. So we do these daily discussions. I want to know if they're effective or not. So in order to do that, I've had this long-running study spanning fall of 2012 to spring of 2019, taking place in our Physics for Life Sciences 1 course and our Physics for Science and Engineering 1 course. The first one of those is an algebra-based course intended primarily for our biology and chemistry majors. And the Physics for Science and Engineering course is a calculus-based course that's typically intended for our math, physics, and engineering majors. So you've got the number of sections of each of those and the number of students surveyed in all of these. Some of these sections used the entire set of faith integration topics. Some of them used a selection, so I'm calling those a partial faith integration intervention, and some of them didn't use the discussion topics at all. So we have here a quasi-experimental setting where we can test the effect of the faith integration itself. We also have a bunch of different instructors teaching these courses. So that's going to lead me to a caveat that I'm going to come to later. What I have here is I've taken a look at all of the topics in our topic set and tried to map them to the 5 axes of the EBAPS to see what aspects of epistemology might these discussion topics impact. The key to focus on here is the center 2 columns. So over in that first column, you see that I've got the topic numbers correlated to each of the axes. And then I just totaled up how many of those topics are related to each axis. So there's a few of the topics on all of the axes in the full set of faith integration topics, but a larger emphasis on that last axis, number 5. So 10 topics talking about that aspect of epistemology. And some of the topics are not particularly related to epistemology. That's okay. In the third column here, we've got the partial intervention sets that some of the instructors chose to use. They're seeing, of course, they're using less, but still a little bit of emphasis on that 5th axis of the EBAPS. Okay, so some study design. The hypothesis here, based on what I showed you on the last slide, because many of the topics were related to the ability to learn science, the hypothesis is that the EBAPS scores will improve on axis 5, specifically when we do the faith integration. So I'm going to try and test that. This is a quasi-experimental study. So the full faith integration, partial faith integration, and no faith integration, those were left to the choice of the faculty who were teaching the course. That I totally acknowledge is a flaw in the study. There was no attempt to control for instructor effects, including other pedagogy sorts of things. There was no randomization of students. We're just doing an observational study here of the courses that had faith integration or not. As far as administering this thing, the EBAPS survey was given during labs in the first and the last week of the semester. That allows us to measure changes in students' epistemologies throughout the semester. And students were only included in the sample if they answered all of the questions on both the pre and the post survey. So I'm going to do some statistical analysis of the data that we've got here. Here we have on the vertical axis the gain in EBAPS score during the semester. And EBAPS is scored on a 100-point scale. On the horizontal axis, we have the 5 axes that the EBAPS measures, as well as the overall EBAPS score. Okay, so some things that you can notice here. Lots of these bars are negative. What that means is they're epistemologies became less expert light during the semester. That's not good, but it actually is really common. All of the research out there on epistemology and the physics education research literature shows that it is quite typical in a first course for students' beliefs to get less expert light. So you can kind of read this as 0 is good, anything positive is great, negative is normal. You can also see here we have some differences between the different faith integration treatments. So I've got those color-coded in the key. Especially want you to notice axis 5 and the overall score. So overall score, maybe I'll start with, you can see that we've got a negative with no faith integration. We have a approximately 0 with partial or full faith integration. That turns out to be a statistically significant difference. So we got a p-value there comparing the full and no faith integration of 0.022. So it's not a strong statistical significance, but it is there. And the Cohen's d on that is 0.21. For those of you who are not statistics nerds, that is considered a small effect size. Okay, but axis 5 is where our hypothesis was focused. So that's where we did most of the faith integration discussions and where we're expecting the largest difference. And that does turn out to actually be true, supported by the evidence. So we're getting large negatives without the faith integration, still negative, but not nearly as bad with the faith integration. So you could read that as the faith integration seems to be preventing some of the typical degradation in students' epistemologies during this introductory course. On the axis 5 there, the statistics, now we have a pretty strong statistical significance, a p-value of 0.008, still a small effect size with the Cohen's d at 0.25. A little bit further digging into this data, what I've done here is I've separated out only the students in the first quartile by their pre-score. So these are students you might consider as being at risk. These are students who are coming into the course with not very expert-like beliefs about science. So they're at risk of not doing well in the course as well as not being retained. You'll notice here that now these are mostly positive. That stands to reason somewhat because if they start out low, there's more up to go. So it's easier to get a positive within this first quartile. And here we're not seeing a whole lot of differences on the first 4 axes, but again, we are seeing a difference on axis 5 as hypothesized. In fact, the only loss we got was for no faith integration for students in the first quartile. So without doing any faith integration, students coming in, believing that they didn't have the ability to do science, that was reinforced for them. And they became even stronger in that belief that they didn't have the ability to do science. But we did get a positive with the faith integration. So that's a good thing. And this is now a very strong statistical significance, 0.001 p-value, and a large effect size, Cohen's d 0.62. So this turned out to be most of the difference in the entire data set was just axis 5 for students in the first quartile. Yeah. Okay, so that's the findings from this study. Let's go a little bit of discussion. So faith integration, we often think about in terms of developing the student's spirituality, helping them grow in their faith. That's valid, but I don't want to stop there. I also think there are benefits that faith integration can and should have for the discipline itself. So as far as physics goes, we want students to have good epistemology. Our faith integration is actually helping with that. I think it's interesting that in this study, we actually can track specific topics to specific gains in the epistemology. So we may be able to target certain troublesome aspects of epistemology to improve. That would actually be a hypothesis for a potential further study. When we're doing a different set of discussion topics, do we affect different aspects of epistemology? Third point here, beliefs are really hard to change. I think this suggests that a potential way towards changing beliefs is actually connecting to values and beliefs that the students already have and showing how that's related. There is a need for more studies. If you look in the faith integration literature out there, there's very little at this point evaluating the actual effectiveness of faith integration. So I'd encourage many of you to think about that. Is there a way you could do studies to get some data on that? I'd also like to go a little bit broader here. So I mentioned earlier there are these 4 themes that our faith integration does in physics at APU. I think a similar 4 themes may work for many institutions and many disciplines. So I'd encourage you to think about that to kind of broaden the way that you're approaching your faith integration. So think about, what characteristics does somebody need to be successful in your field? And how might those be related to their faith? Are they virtuous? Are there vices that are characteristic of people in your field? Those might be things worth talking about with your students. What's the nature of the field? What are you assuming? How does your field impact society? How can we use it to make a difference in the world, to show love to people? And the theological implications, that's going to be pretty specific to whatever discipline you've got. A few quick resources here. The first of these resources is the description of the curriculum itself for the entire faith integration in the physics program. Feel free to shoot me an email if you want resources on any of that. The second of these here is the study, which was published in Christian Higher Ed last fall. Okay, so that, I think I'm going to stop and take some questions. The question in the chat, Julie Main, the EBAP survey is not available in the paper, but it is available just online. If you just Google EBAPs, you'll find it quite readily. Micah's question in the chat, did I try to parse out the data by instructor? I did look at that, but when you start separating it out, the sample sizes got too small to really tell any particular difference. One difference that I actually forgot that I was going to say as a flaw in this study is most of the sections that use the full faith integration were me. So I'll admit that this study is a little biased and not properly controlled. Though I will say the one other instructor who did use the full faith integration set, he also got good epistemological gains.
We have a question from Rachel Miller.
Mm-hmm. Okay, can I speak a little more on the topics of faith integration? Were these developed by my university or developed for this study? So the topics of faith integration, they're really broad. I kind of think of it as a tapestry. So there's 36 to 39 just in this one set. And then if I was to include the other 2 courses in our intro sequence, I have something like 130 questions total. So, and maybe I'll just throw a couple of other examples out there. So the one example I showed you in the talk was about criticism. I've got a whole sequence on mad scientists as some of the vices that scientists are known for. I've got quite a few on how to do the work well, what sorts of habits are useful. When it comes to the science and society things, it's all hot button topics of science making a difference in the world. When it comes to the theological implications theme, then we're talking about things like the implications of quantum mechanics and the Big Bang, and going really broad. So feel free to shoot me an email. I'm happy to give the full set of questions to anybody. And I do know some people at other institutions who have used them and had some success with them as well. As far as the second part of Rachel's question, these were developed by me, not particularly for this study, but I developed them before the study and then kind of post hoc put the study on afterwards. That's why it was not terribly well controlled. Our administration has been encouraging us for decades now at this point to really think how comprehensively we're doing faith integration in each of our majors. So that was the impetus behind this.
Any additional questions for our speaker?
Mine would be kind of a follow-up to Rachel's. So how well, so did you guys sit down as a department? I don't know how big your department is, and decide what those, faith integration topics were going to be? You developed them by yourself, and how well do you think other departments do that?
Okay. So yeah, we had several rounds of sitting down and brainstorming. As a physics sub-department, we're actually a department of math, physics, and statistics. That's 4 of us, so it wasn't terribly hard to brainstorm. The topics themselves, I did write after reading very extensively. I have a hugely long bibliography at this point, and was just kind of collecting ideas over about 5 years or so. After I did all that reading, then they started clustering together into these themes for me. And I brought that back to the department and said, this is kind of what I'm thinking. Give me some feedback. And we hammered out some of the details of what to put in each course and got consensus on we actually want to do this as a department that's accurate. As far as other departments, some do it a lot better than others. Our mathematicians also do really well. Our biologists do really well. Some of our departments are leaving it just to all of their instructors, and they'll just tell their instructors, come up with something. The trouble is then they all keep coming up with the same thing, and the students see the same assignment 10 times by the time they graduate, and it gets really boring. So that's why I also encourage to think about comprehensively throughout the program how that might
right. Be. So you're saying there's no integration like across all the sciences or all the humanities with those themes?
Not currently, no.
Yeah.
Okay, we had a couple of questions from Ted Grant in the chat. They were graded just on participation in the discussion. So that was 4% of their overall grade, just posting in the online threaded discussions. Were the integration discussions more of a class effort? During class, yeah, we just have a discussion with the whole class, almost seminar style for the first 5 minutes of the physics class. And then they continue their individual postings online. But it's still a discussion online. I still have them respond to each other so that they are reading people's thoughts and things.
We again want to thank Dr. Lewis and Mr. McCoy from Azusa Pacific. Thank you, everyone. And I hope that you will enjoy the rest of this conference. We are very excited for all of you.